And when you got k equals to 2, you figured out that, yeah, like right now your complexity is going to be n cube. Yes.
Yeah. Okay.
So similarly, like in the other cases, as we were increasing, we figured out that if it is k, then our complexity is going to be n to the power k plus 1 divided by k plus 1. Clear?
Ma'am, why are we not considering the upper loop? I think the answer should be n into order of n to the power k plus 1 divided by k plus 1.
Can you repeat again, Aman?
Yeah, we are not, ma'am, we are not considering the upper loop. That is for int I equal to 1, I is less than equal to n, I plus plus.
Okay. See, we
Yeah,
are considering it, right? Because if I is running, then only you are getting that particular. Just a minute. Yeah, if I is running, then only you are getting 1 power k, right? And then your inner loop is running for 1 power k times. Then for the next time when your I becomes 2, then the p value becomes 2 power k, and then it runs for 2 power k times the j loop. Are you able to follow this?
yes, ma'am.
So this n times that your addition is going on, like 1 power k plus 2 power k plus 3 power k, it is actually nothing but your I loop running. And the
Yes,
individual
ma'am.
values indicate the j loop.
Yes, ma'am.
I hope you are clear.
Yes, ma'am.
Okay.
One more.
Yes.
Yeah,
Yes,
I'm
yes.
clear on this fifth question. Now, one question I had, like this, just my observation,
Mm-hmm.
like the ON, it does not give accurate number of instructions. Like for example, just
Uh,
question number 2, and when I compare to question number 6, say in that question number 2 there are two for loops, but
mm-hmm.
in question number like 4 and 6, it is just like half, or like very very less value, but
Let me
both of
just
them.
see.
Yeah,
You are talking about question number 6. Okay. Yeah.
yeah, compare it
So,
with 2, both have answer as ON.
and question number 2. Okay. Both has answer as order, but second is order of n square, right?
Yeah, and about 4 is also n square.
Let me see it. Just a fourth is having it as, sure. Um,
N into n
guys,
plus
if anyone noted it down, can someone tell me what was the Yeah, I guess it is order of n only.
Order of n.
Yeah, it's order of n.
just 1 second, how, like, because n plus n by 2 plus n by 4, and it goes on until n,
Hmm.
so the sum would be n
So
into
we,
n by 2, so
mhm.
so it is n square.
Actually, when you give like when you get this, you have this particular formula to be solved. Okay, this is a GP series. Then we solved it in here. So your first term was n. R is nothing but the division between the second term and the first term. So that we get as 1 by 2. So we applied the formula, and when we solved it, we got here order of n. Like it has not came out of like anything, but it is like coming out of a formula. Clear?
Yeah.
Yeah, and
Mm,
if you also see it in this way, that amongst the addition series, the biggest number in your series is n. Okay. And you
mhm.
must have seen that whenever addition comes up in the time complexity thing, I have told you all that in those cases, always the bigger term gives you the time complexity, right? If you remember it.
Okay.
Okay.
Okay. What sixth is also like same thing, no?
Sixth, yeah. Sixth is having two loops, but yeah, its the complexity is coming out to be order of n. Order of n square, I guess, not order of n.
Order of n, ma'am. Because there are question
No, it's order of n square.
7.
No,
For
six.
seventh, for sixth, it is order of n square because you can clearly see that it is
Yes,
running
ma'am.
from like n till like 0, and every time it is getting divided by 2. So like if you observe here, the values are being like same as the this fourth question, right? For the ith loop. Are you able to notice that?
Yeah.
But there is one inner loop as well which is running, right? So because of that, inner loop is giving the complexity as n, outer loop is giving the complexity as n, and overall it is becoming as n square.
Okay.
Vishnu,
So
is
when I
it
compare,
clear?
yeah, when I compare 2 and 6,
Mm-hmm.
both have on square, but their instructions are like dramatically different. Like one is, there's a huge difference, is n square is uh, like if we like
Mm-hmm.
just compare 2 and 6, uh, here it will be like, if it is 1000 into 1000, it will be 10 to the power 6, but in case of 6 it will be like something like a very small value because it's
No,
decreasing.
it won't be a very small value, but it will be very close to n square. So I told you that day that Big O has a very Big O has a disadvantage. That is that we always have to consider the worst case. Okay. So we can't even take the average case and say that, okay, the number of instructions are less. So probably the time of execution will be less. So always you have to consider the worst case. So what will happen in the worst case, you are going to get a good time complexity. But for the average and best case also, you are going to get the worst case complexity. Clear? Like you can't deal with this particular issue and say that instructions are less. So its time complexity should be less. You have to always deal along with the worst case only.
Yeah. So in 6, what is the worst case? It will be always like very
It's order of n
fractional
square
value.
only.
Yeah, but when we compare with 2, this will be very fractional compared to 2.
Why?
Because here it is decrementing by half every time, and there it is decrementing by 1,
Incrementing by 1.
incrementing by 1. Yeah.
Correct. But for the first case, you can see if I is equals to n, it is running for the entire n times.
Okay.
When I is n by 2, then the inner loop is running for n by 2 times, right?
Right. Yeah.
So roughly, if you will see, it is running for somewhere around n. The inner loop, I'm saying every time it is running around n times, right? Not able
It-
to get it.
no, no, I'm getting halfway because it is decrementing half, 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 and other is
Your point is right. But what I'm trying to say here is, just a minute. What I am trying to say here is that you are getting this particular point that outer loop is somewhere running around n because you saw this particular
yeah,
values in the fourth question, right?
yeah,
And you know that here it is going to be n.
yeah,
Inner loop, you also know that somewhere it is running for n times each time, like initially n, then n by 2, then n by 4. So roughly we will consider that every time it is running for n time because in the worst case we are getting it as n,
yeah.
right?
Okay.
Hence, because of the worst cases, we are getting it as an n square. Clear?
Okay.
So we can't neglect the worst cases. Okay.
Okay.
Yeah.
Thank you.
Yes. Now, those please respond who has finished this table. I want to see who was dedicated enough in these 3 days to do at least this simple problem.
I'm just thinking it loud that the only difficult part is getting the login. Uh, so
It's not that difficult. I'll solve that in front of you all. N square, that is, I'll just write here.
10 to power 12
N square will be your 10 to the power 12. Log n, just a minute.
to the base 2 or 6.
Log to the base 2. And here it is like 10 to the power 12. Right? Sorry, not 10 to the
6.
power 12. It's 10 to the power 6. I gave you some calculation over here. That 10 to the power 3, assume it as 2 to the power 10. So 10 to the power 6 will be equals to
20, 2 to the power 20.
everyone else. Are you sleeping in the class? Okay, I'm not gonna teach until I get at least, okay. So always you guys need this kind of scolding and then only you start responding. 10 to the power 6 will approximately be equals to 2 to the power 20. So here you will get log 2 to the power 20. This whole thing will cancel out and you're going to get 20. Able to follow this? Everyone in the class, are you able to follow this? Okay. Just a minute. So overall, you're going to get here the value for n square log n as 2 into 10 to the power 13, right? 10 to the power 12 was always like already there. And then 20 came up. Clear? And when you will try to convert it in terms of time, what will come out? It will come out as 5.55 hours. Good, Gaurav and Mohan. Next is n square. You already know that it is 10 to the power 12. What will be the time for this? Calculate it right and then tell me. It will be approximately equals to 10 to the power 3 seconds. Don't tell me the answer in hours if it is in point. Try to tell me in minutes also, it will be fine. It's approximately 16.66 minutes. So I'll just write it as 16.67 minutes. Then n log n, it will be approximately, now you know that log n value is coming out to be 20. N was 10 to the power 6. So it will be 2 into 10 to the power 7. Next, what will be the time for this? It will be 0.
Ma'am, 1 second.
0. Mhm.
Actually, in 1 second, 10 to the power 6 instructions are happening.
In 1 second, 10 to the power 9 instructions are happening.
Okay.
That you know, no?
Oh, I got confused with the n at the top is n equal to 10. Now I'm clear. Okay.
Yeah.
I'm fine.
That is a fixed value. It cannot change ever. Okay. N, it will be 10 to the power 6. What will be the time for this? What will be the time taken for this? It will give me the exact values, guys. It will be 0.001 second. Okay. Under root n. Under root n will be having number of iterations as 10 to the power 3. And what will be the value for time?
Shouldn't it be 10 to the power 4.5? Now, why I'm
It's
saying is
10.
root n is when we take half as a power on 10 to the power 9.
It's this. If you take under root of 9, what it comes out to be?
3. But then when we are square rooting 10 to the power 9.
Yeah, but it is 10, right? Like if you square root 100, what will you get?
10.
If you square root 10,000, what will you get?
10 to the power 2.
Right, 100, right? So if you are squaring like 10 to the power 6, you will get 10 to the power 3, right? Like just the half of the 0 digits.
Oh, okay, okay. Yeah, I got it. I was confused with 1 second equal to 10 to the power 9. Thank you.
It's fine. And here it will be approximately 1 into 10 to the power minus 6 seconds. You can add all the zeros in front of 0.00001 seconds. That much is the value going to be. Log in, it is going to be 20. And if you try to find the time for this, it is going to be 2 into 10 to the power minus 8 seconds. Clear, everyone? So you all can see here that whenever we are like, you all know for binary search, the time complexity is, for binary search, the time complexity is log n, right? So its time complexity is log n, and you can see how much time it hardly takes to execute your search results. So everywhere where you see the searching algorithms, you can see it in everywhere. Every website you go in, no one wants to like just keep on scrolling and search for these things. They just directly go to the search bar and find their things. So wherever searching is happening these days, maximally they are using the binary search. And that's why it happens so quick. Even on our WhatsApp, in our Instagrams, Telegram, everywhere you can find this feature. Clear to all?
I have a small doubt.
Mm-hmm.
In wherever like WhatsApp or things, the data is in alphabets
Yeah,
and they are unsorted.
yeah.
So how can we apply binary search there?
They apply the sorting.
I'm just imagining like in WhatsApp, if I type hello, it will
Hmm.
search all the conversation which has hello. So this is a string, and we are searching string in an unsorted array.
Actually, see, I am saying that it is applied in the places where it is possibly being applied. Like wherever you can apply it, there it is being applied. But the places where like linear search is more feasible than binary search, in those places we do not do it. But like you can see it in the search feature in the WhatsApp where you are like searching for your contacts. In your call logs, you are searching for your contacts. There you can see that they have already kept it in a sorted manner, right? Like
Okay.
in your call name, like in your names, they are
Yeah,
arranged in the sorted manner, right? So whenever you are searching it, can we say that their binary search is getting applied?
yeah, yeah. Got it.
Yeah. Now here 2 to the power n will be 2 to the power 30, and 2 to the power 30 will be approximately equals to 10 to the power 9. Clear to all? Because we already saw that 2 to the power, just a minute. We already know that 2 to the power 10 is approximately equals to 10 to the power 3. So we have to multiply 2 to the power 10 for 3 times. And on the right hand side also, we have to multiply 10 to the power 3 for like 3 times. So here we will be getting 10 to the power 9. I'm writing these all calculations for those who are confused with these things, okay? So here I am writing it is 10 to the power 9 iterations. The time taken, you all know for 10 to the power 9, how much time will be taken? It will be 1 second. For n equals to 60, how many iterations? 2 to the power 60. Approximately how much? For 2 to the power 60, how much iterations?
10 to the power 18.
Yeah, right. So it will be 10 to the power 18. And again, you all know the time for this. It is approximately 10 to the power 9 seconds, which is nothing but again equals to 31.7 years. So these kind of problems generally happen, like 2 to the power n kind of problems generally comes in recursion. Okay. Like whenever you are thinking of a recursive approach, it's like you have to consider all the possibilities. And there the complexity come out to be 2 to the power n. So though we all are easily able to implement the recursive approaches, but in those cases, the complexity is way too much. So whenever your program is giving you 2 to the power n, just at least see the constraint and see if it is feasible solution or not. Clear to all?
Ma'am, what is recursion?
Recursion will come, Aman. I just introduced that particular topic name as of now. So when we will learn, like we are going to learn recursion, you will find it out.
Okay.
Okay, yeah. Anyone else having any other questions, you can ask. Okay, then if you have no questions, then we'll just start on with stack and queues. So anyone know what is a stack? What is a queue?
I think like it's a linked list where the items are added in a stack. It is first in, last out, and queue is first in, first out.
It can be anything, not only linked list, I'll say. You can use any type of data structure, and it's just like that you just keep on entering your items into, you can say you have a box which is closed from this end. I kept one item in it, it is filled. I entered another item, filled again, and this way this particular box is filled. Okay, now when it's time to take your items out, when you want to unpack your box, then what will you do? You don't have any way to take this particular item first. Do you have? No. So what we have to do, we will take first this item out, then we will take the other one out, and at the end we will get the very first item we entered into the box. Clear to everyone? And this particular technique is known as LIFO technique, or you can say philo technique. If I name philo, it is nothing but first in, last out. You already saw that I entered this first item in the box and then I take it out at the last. Yes or no? In the same way, you can say it in this manner: last in, first out. That is, I entered this last item on the like top of the box, but I take it out on the very first. Clear? Coming on to the queues, what queues are? Queues are basically a two-way street. It's like a box which I can open from the end also. Okay, like it has an opening chamber from the below. Let's just make it in this way only. So if I entered the first item here, second, third, fourth, fifth, but it only has the provision that we can take our items from the first only. Like the way I entered, I will take it out in the same way. That is, if I entered the first item in, then I will take out the first item first. Also, if I entered my last item at the very end, then it will be taken out at the end only. Clear? So the technique which queue follow is known as FIFO or LILO. We can say it as first in, first out. And these are not any kind of data structures. These are just a kind of technique which is being followed. Clear? And for this, we can say that last in, last out. Coming on to the stack first, there are certain terminologies that stack and queues use. Anyone know of what terminology we use for the stack? Okay, you all are aware. Whenever we enter any item into our stack, that particular operation is known as push operation. Okay, push, and it is a parameterized function so that we can enter our item into it. There is one more, that is pop. Whenever you want to take out your top item, it is used for pop. Like that particular term is known as pop. Clear? Guys, is it clear? Okay. And you all can see that one by one, we are entering the items, then we are removing the items, then we should be having some count of it, right? Like we should know that where is our top element right now, where is our like bottommost element right now. We should be having some type of counter, right? Otherwise, how will you know where to enter? So, okay, how many pointers should we actually have in the stack? Okay, I want multiple answers. Someone is saying 2. Someone is saying 1. Okay. Okay. Yeah, it's 1 only. There is no need for 2 because you entered one item. You have, yeah, like you will move your pointer to this element. Again, you entered one more item. You will move your pointer to this element. Is it needed here? No. Then it will be moved. Then let's suppose you entered one more item. Your pointer will be moved on to here. Now let's suppose I want to remove the item from the top. I removed it. Once I removed it, is there any need of your pointer to be here? No. It should be moved on to your previous element. So overall, no matter what you are doing, whether you are inserting an element or removing an element, only one pointer is needed. Clear? Guys, is it clear? Okay. Okay, now I'd like to ask Ashish, is it clear to you? Ashish, is it clear to you? And Kalidas, Kishan, Bhuvnesh, Kishore, Mohan, Mani, Richa, Vaibhav, Vipin, Vishnu.
Yeah, I'm clear, ma'am. What's the question?
Question was that whatever I've explained so far, is it clear to all?
Yeah.
Okay. Okay, then imagine that I have made an array which I'm considering it as a stack. Yeah, and one more thing. The pointer that we were discussing about in the stack, it is known as top pointer because no matter what, it always stays at the top. Clear? Okay, then we will just quickly see how the operations are being performed. I will give you few operations here. Wherever numbers are written, it means that you have to insert that into the stack. Wherever I am giving the upward arrow, it means you have to do the pop operation. Now, number one, when 3 will come to be inserted into the stack, what we will do? Which operation should be performed? Guys, be quick. Guys, we have to insert 3. Push, right? Can anyone tell me when your stack is empty, where will be your top pointer? What will be the position of your top pointer? Basically, there is no element in your array, right? So you can take top equals to -1, which is like here.
So I'm missing one point. What is our goal here?
We
are
have to insert, push the element in the stack.
and a stack here is an array.
Yeah, it can be anything. It can be an array, it can be an array list. We just have to insert the element in the LIFO manner. Clear?
So all we have to do is check the index and then put that element.
Correct.
Okay.
Now you have to insert your element at the 0th index. What will you be doing? How will you insert it? We have to move pointer to 0 and then we have to insert it, right? So it can be written as array of, I will write here ++ top. So it will get incremented first and then equals to 3. Will it work? Yes. Inserting 10, again it will be the same thing. Array of, let me just first clear these things out. Your top initially was at -1. Afterwards, it reached to 0 and you will be inserting here 3. When 10 comes up, you will again do this operation, array of ++ top equals to 10. Again, the pointer will move from here. It will go to 1 and it will insert here your number, that is 10. For -1, again, the same thing is going to happen. Array of ++ top equals to -1. So what will happen here? The pointer will again move. It will come here. -1 will be stored in your array. Or sorry, not the array, it is stack. Clear? Now coming on to the pop operation. What should happen in the pop operation? Um, yeah, okay. We only need to move our top element, right? That is, if I just do top minus minus, it will do my work, because when my top will be here at one position, no matter what is there in the second position, it doesn't matter. Because when the coming number will come, like let's suppose 12, 12 will come, what will I do? I will just increment my top again. Let me just write it. I will increment my top again here. And I will write here equals to 12. I am not even checking which number is there in this index. So should I actually need to delete this number? Not required.
Ma'am, 12 will replace -1 or it will move further.
I didn't get you. Can you repeat?
Ma'am, after performing the operation top minus minus,
Mhm.
-1 is removed from that array.
It
And
is not removed. It is just like your top was here, no? So it
yes,
comes
ma'am.
to here. That's it.
And if we want to insert 12, then
Mhm.
where
Then simply
will it
do the
store?
same operation.
Yeah, then what is the index of 12?
It will be 2.
Okay,
Got
yeah,
it?
got it.
It
Yeah,
will be overwritten.
okay.
Clear to everyone or not?
Ma'am, I have a small doubt. Like if I am trying to check the index of that array after top minus minus, it will be 2, and before top minus minus, it will be 3. So
No, no, no. Why it will be 3?
because there are 3 elements before top minus minus.
Yeah, but when you did top, like plus plus top here, your top becomes 0.
Oh, no,
Because
number.
initially it was at -1, right?
Oh, sorry, I meant size of the array.
Yeah, okay. Now you can say. So see here, since it is in stack, you cannot find the size using your like normal functionality, that is array.length.
Okay,
Okay, because that is not going to give you the correct length for the stack. Clear?
okay,
How
okay.
will the size function work here? Can anyone tell me?
Mm,
Size of stack.
will it be 10? Because
No, stack is only up to here. It is a dynamically growing, like you can say, data type or data structure. The size of the stack will be, as some of you already told me, top is at 2 and you have total number of element as 3. So it will be nothing but top value plus 1. Clear? So when I will do top minus minus, in that case also what will happen? It will go to index number 1. And if you will find the size in that instance, you will be getting it as 2. Is it clear, Vishnu?
uh, actually, I have a doubt because like I'm trying to understand that size of stack is the place where the pointer is. Is that what you mean?
Yeah, up to where the numbers are stored.
But if you see pointer wise, it is at location index 1, but it is filled up till 2.
But I am talking about only up to the digits where your top belongs to, okay? Because
Okay,
obviously the deletion operation will happen, and I just told you that you are not actually deleting the numbers. You are just moving your pointer.
okay.
Clear?
So I mean, the pointer is decides what the size is.
Correct.
Then
Pointer
I'm fine.
decides where your what is the size of your actual stack.
Okay, thank you. Yeah. Okay.
You can take it as an example of the queues, or you can say the yeah, you can take the example of the queues in the banks. Okay, there is a huge queue in the bank, but now that bank decides that okay, now we have to close, they just put like you can say a border in front of half of the people, that only these much people are allowed for today, the remaining will have to come tomorrow. Okay, so this like the line is very big, but what will be the size of the actual number of people which will be going, like who will be going in? That will be small, right? Are you getting it?
Yes, yes, yes.
Okay. Okay, then. So yeah, we did it for the stack. The like anyone knows the like the naming for the queues? like the way we did it for the stacks. It
Ma'am, I
is
have,
push, pop, top, size. What is it about the queues? Yeah, you can continue. What
ma'am, one question. Like in Java, we don't have pointers. Only in C, C++ we have.
It's
So,
pointer in the sense that I'm just saying you have to maintain a pointer. It can be any kind of variable, right?
okay. I mean, isn't it like memory allocation?
No, 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 it's not
Just
like that.
Ma'am, yeah. Hello.
okay,
Yeah.
got.
Ma'am, the final array will be 3, 10, and 12, right?
No. Final array will be up to 12 and then there are two pop operation, right? Are you
Ma'am,
getting
what?
it?
Yeah, what will be the final array?
Yeah. So see, this will be overridden as 12.
Yes, ma'am.
Then two pop operation will happen. So your top was here, then it will move to here.
Yes, ma'am.
Again, one more pop operation will happen and it will go to here. So at the end, your stack will be having only one element.
Yes, ma'am. Got it.
Clear?
Yes.
Anyone else having this question? Guys, today is the day you can be clear with the concept of stack and queues. We will move on to the questions tomorrow only. So just if you have any kind of doubts, any silly kind of doubt, you can just ask.
Ma'am, one question. Just like
Mhm.
regarding the size, you said that it is top plus one, but like I can remember I read it somewhere that stack also has a size method.
Yeah, it do has. See, we are implementing here, like I'm telling here, that it is top plus one, right?
Mhm.
And internally, what stack functionality is being implemented in Java, in there, the function says that like whenever you will go into the function of the like size function of the stack now, you will find it there that it is written as top plus one or whatever variable plus one. Is
Okay.
it clear?
Yeah.
Like whatever they has done is like, how can I explain it to you? Like people say that for sorting the algorithm, the time complexity for it is n square and n log n, right? So what do you think that internally your arrays.sort function should be implementing? Any ideas? You all know that you have a sorting function for the arrays, like you write arrays.sort and it gets sorted. What type of sorting algorithm do you think internally is being implemented? I guess Richa was the one who asked the doubt, no?
Oh, no idea, ma'am.
It's merge sort only, like which will the least time complexity the algorithm takes, that is only being implemented in your predefined functions. Okay, so whatever I'm telling you, the best time complexity in terms of searching, it always implement binary search. In terms of sorting, it always tries to implement the merge sort or like quick sort, not even merge sort, quick sort. Clear?
Yes, ma'am.
Okay, great. So in terms of queues, if I talk about the operations, for pushing the numbers into the array or for inserting the numbers into the queue, the operation is named as enqueue. For deleting the number from the queues, that operation is known as dequeue. There are, as I told you, that in a queue, you will enter a number. Okay, like let's suppose I entered the numbers, but you will always delete it from the front. You will enter from the back, but delete from the front, right? So for that, you have to maintain two pointers, one for the insertion, one for the deletion. Yes or no? So for insertion, the pointer is known as rear pointer, the one at the back, and The pointer at the front, which is used for deletion, it is known as front pointer. Clear? And instead of this, size function will be the same in both of them. Can anyone tell me what will denote the size of the queue? Okay, we will come out on this later. As of now, let's just do the same functionalities here also. Yeah. For the insertion, can anyone tell me what will be the operation? NQ is obviously here, but the function I am asking what I should write. It will be like array of, you will obviously, you know that when there is no element, your rear pointer, just a minute. Yeah, your both the pointers will be at -1, right? When no element is there, it is -1. So what will you do? You will increase your rear first of all. And now you will insert your element, that is 3. Clear to all? Now coming on to 10, again, it will do the same thing. Array of plus plus rear is equals to 10. Again, for -1, it will be array of plus plus rear equals to -1. Clear everyone up to here?
Ma'am, I have one doubt.
Yeah,
NQ is the method name or like just a concept?
it's a method name which which we write generally for the insertion in the queue.
Oh, I was confused with. Yeah.
Like we did there, the push operation, right?
Okay.
Yeah.
So it is equivalent to push.
Yeah, like I was writing there push and bracket, I was writing 3, right? So here we can write it as NQ3.
Yeah,
Clear?
got it.
Okay.
Yeah.
Now coming on to the deletion, here it is written the pop one. How will I delete the element? Which pointer should I move so that I can get this element, like can delete the element?
DQ
Kishan?
of minus front.
Okay, I'll just take it by one. Kishan, first of all, we cannot delete from the rear end because rear end is for insertion and front pointer is for deletion. So that is wrong. Jyotsna, you have written front minus. Your front is already at -1. Okay. If you further do it minus, it is going to be -2, which is not deleting any element. And Abhijit, array of plus plus front is of no use because you are not inserting any element in that particular array index, right? You just have to move your pointer. So that you need to think of. And yeah, Vaibhav, you are saying front plus plus. Okay. But when you do front plus plus, it will come to 0, right? But at 0, you should not be there. You have to delete this particular element, which means your front should now be here. Yes or no? If you have deleted your first element, after that your front should be at 1, not at 0. For this purpose, what we do, initially when your queue is empty now, like there is no element, and as soon as first element is getting entered, at that instance, you just increase your front as front plus plus also. You check this condition. If your front is equal -1, you just increase it. Clear to all? And afterwards, whenever deletion operation comes, what you need to do? You need to do front plus plus. Clear? So when your front was already at 0, now if you will do front plus plus, it will come to 1. Anyone having any questions in this particular concept of front?
I'm sorry, I didn't get this part. So when we are doing the NQ, both pointers are moving simultaneously.
For the first time.
Okay. So for every push, it will every NQ there will be forward movement. For every
No,
DQ, there
for
will be a
every NQ, there won't be forward movement. For front, only rear will be moved. Clear or not?
no. So at what
Okay, let me put it in
time,
this way.
when will it differ?
See, initially both is at -1,
Mhm.
rear and front.
Yeah.
For the very first time, that is for the first element you are entering, only for that case, you have to increment both rear and front.
Correct.
Afterwards, whatever NQ operation happens, you need not move your front. Clear?
One
For the
second.
NQ operation.
Yeah, I got it now.
Okay. Then for the DQ operation, whenever it comes now, what you just need to do, you just need to do front plus plus. That is, if your front was at this 0 index, you have to delete it. That means now your front should be here. Clear?
So first remove, then front plus plus.
Removal in the sense, just move your pointer. That's it.
Oh, I forgot. Yeah. Then how will the size work? It will be difference between front and
You
rear.
need to tell me.
Okay. Yeah.
Here it is your 3. Let's suppose I entered 3 initially, then 10, and then I entered -1. Your rear will be at this particular index 0, 1, 2. Your front will be at 0. What will be the size?
So actually, technically, it should be 3 because there are 3 elements between front and rear.
Yeah, so any formula for that?
So without deletion, it will be 3. After deletion, it should be 2.
So how will you know that? Anyone, do you know the formula for this? Rear, I'm not getting it. Bhuvnesh, what you are saying? Kishan, it will be opposite. It will be rear minus front. If you will do rear minus front, 2 minus 0, 2 plus 1. This is the formula for size. Clear? Vishnu, is it clear to you now?
No, I still have a doubt that when we are doing DQ method, then the size prior to deletion would be 3, post deletion it would be 2. So which one should we consider?
Obviously, you have to consider 2 because the element is already deleted now, no?
Post del, okay. Yeah. Post DQ it will be 2.
Yeah.
Prior,
And before DQ, it will be 3.
ठीक है, अभी clear.
Okay. So yes, we just saw the comparison of 4 operations in the stack and queues. In the stack, it is push for insertion, pop for deletion. In the queues, what operation is for insertion? It's NQ. What is the operation for deletion? It's DQ. the pointers which we use in stack, it's top, and the like the pointers which we use in queues, they are rear and front, clear, and the size operation is same in both of them. Just the difference of the formula is there. For the size function in stack, it is top plus 1, and for queues it is rear minus front plus 1. Clear?
The final array of Q is, I think, 12 is the only element in that array, and the size will be 1.
Let's just see it. So yeah, when you will do the DQ operation here, 3 will be removed, right? Then 12 will be inserted here.
Yes, ma'am.
2 DQ operation, 10 will also be removed, minus 1 will also be removed, 12 will only remain. Clear? Good, Aman, it's right. So like there are so many type of queues which are going to come, but as of now, these were the basics for stack and queues. So I'll just like end the class now, and we will